Hello everyone. So we now continue our lesson. No. So this time we now proceed with problem number two. No. Okay. So we have problem two. So here's problem two. So we have the crest gate shown consists of a cylindrical surface of which AB is the base. Okay. So AB is the base supported by a structural frame hinge at O. No. So the length of the gate is 10 meters. So here's the length of the gate, it's 10 meters. Okay, and we are to compute the magnitude and location of the horizontal and vertical components of the total hydrostatic force on AB. Okay, so we're going to find the magnitude and location of the horizontal and vertical components of the total hydrostatic force on AB. So we are going to determine F sub 1, which is the magnitude of the horizontal component of the total hydrostatic force on curve AB, no? On gate AB. Then F sub 2 is the magnitude of the vertical component of the total force of the total hydrostatic force on AB. Then F1 location, then F2 location. Okay? So we're going to solve for the horizontal component of the hydrostatic force F1, vertical component of the hydrostatic force F2, and the location of the two hydrostatic force components. No? So we can now proceed with the solution. So for the solution of the problem, so we consider first finding F1. So we're going to consider the vertical projection of the gate. So here's the vertical projection of the gate. No? So in here, we locate the center of pressure. So here's the center of pressure. Okay, and now we have this um, the right side view of the gate. No, so the vertical projection of the gate. Okay, then we consider the right side view of it. No, kasi meron siyang third dimension, right? So ito yung kanyang vertical projection, yan. Tapos yung sa kanyang third dimension nandoon. Okay? So, eto ngayon, ano siya, rectangle. Okay? So, in that case, we have the centroid of the vertical projection. Okay? So, ito yung centroid niya. And take note, this is 10 meters. Kasi the length of the gate is 10 meters as stated in the problem. So, if that is 10 meters, so 10 meters yung kanyang third dimension. So, ito yung right side view ng gate. Right side view ng vertical projection ng gate. Okay? Right side view of the vertical projection of the gate. And in that case, so ito yung ating horizontal component ng ating hydrostatic force, F1, no? Which is located at the center of pressure of the vertical projection. So ito siya, no? Dito. And then, so ito yung nahanap natin, F1. So yung F1 is equal to the specific weight of the liquid multiplied by H sub C. Okay? So, ito yung ating H sub C, so specific weight of the liquid, H sub C, ito yung distance between the water surface down to the centroid of this vertical projection of the gate. Then the area, and also the area of this right side view plane, no? Itong plane na to, okay? Area ng right side view plane. So, in that case, ano yung area niyan? Right area ng rectangle. So, that is simply BA. So, alam natin na this is B, right? So, this is equals to B. Okay? Ito. B equals 10 meters. So that's why we have, so we consider the temperature of water at 4 degrees Celsius. Okay, and then half of the HC is half of the total length A. No, itong A na to, kalahati. Kasi centroid eh. Pag centroid, no, ang pinag-uusapan, pag rectangle, so ang centroid ay kalahati nung total length nung side na to, yung A side. Okay, kasi rectangle siya. So naturo ko naman yan before, no? So pag-aralan nyo na lang ulit kung nakalimutan na, no? Kung paano ma-determine yung coordinate ng isang centroid, no? So in this case, so that is 1/2 A or 0.5 A. So yun ang ating HC, 1/2 A or 0.5 A. Then area of the rectangle, that is BA. So that is 10 meters times A. So alamin natin ano yung A, no? So let's determine ano yung A value. So in that case, no, A is 10 sine 60 degrees meter. So paano siya naging 10 sine 60 degrees? Okay? So take note, this is 10, right? Ito 10. Tapos ito yung 60 degrees. So tapos ito yung A, di ba? Ito, yung A na yan. Okay? Ito yon, yung A. Yung distance mula dito hanggang dito. Okay? So ano yan? Right triangle, right? It's a right triangle. Ayan. And this is 60 degrees. Okay, and this is 10 meter. So this is 10 meters. Okay, and then this is A. Okay. So ang ating A ngayon is equals to, so that is Sokatowa tayo, di ba? Sokatowa. So sine 60 degrees is opposite over hypotenuse, no? Opposite over hypotenuse. So meron tayo ditong opposite over hypotenuse. Ayan. So ito yung ating, ito yung B natin. Okay, ito yun. Actually, sorry, hindi should be itong side na to. Sabihin natin ay Z. Okay? Sabihin natin Z. Pero hindi natin concern yan. Kahit wag na natin lagyan ng letter. Ang concern lang natin ay A. So ito yung opposite side. No? Kasi ito yung 60 degrees. No? Opposite side with respect to 60 degrees is A. So you know that, right? And 10 meters is the hypotenuse because this is a right triangle. Right? Ito, right angle kasi yan. No? So this is a right angle. So therefore, this is a right triangle. Itong triangle na may opposite side na A, 10 meters na hypotenuse. No? So now, opposite is what? Is A, right? Opposite is A. Hypotenuse is 10. No? 10 meters. So therefore, ang A natin ay, so yung 10, multiply natin sa sine 60 degrees. So 10 sine 60 degrees. Okay? Meters. Kaya nakuha yan. 10 sine 60 degrees meter. So we proceed. So the unit weight of water is 9.81 kilonewton per cubic meter. Then 1/2 of A. A is 10 sine 60 degrees. Then B is 10 meters. So ito yun. No. Ito yung ating B, no? So, and then, ang ating A ay 10 sine 60 degrees. So, we will get an answer of 3,679 kilonewtons. Okay? Next, consider naman natin yung part na to. So, ito yung ating center of pressure. Okay? And then, ito yung ating pressure diagram. Kasi rectangle to, vertical, ano yan, itong side na to, no? Yung side na to, yung front view side ng vertical projection, no? Itong vertical projection na yan, okay? So, sa left niya, merong water, okay? At nagva-vary yung water, no? Uh, nagva-vary siya sa ganitong distribution, triangular distribution, okay? Hindi siya uniform. Kasi pag uniform yan, ang diagram natin ay rectangle. Kaya lang, in the past, naturo ko na yan na ang pressure diagram ay triangular. No? Kapag ka vertical ang pinag-uusapan, no? Kasi vertical lang ating projection na to, vertical. Kung vertical ang pinag-uusapan, triangular yung kanyang shape, no? Yun sa pressure diagram na naturo ko na dati. So, meron kang pressure distribution that varies in intensity as we go deeper. As we go deeper, it varies in intensity. Okay? So, habang paidalin ka, lumalakas yung pressure. No? So, in that case, okay? So, ito, nagkataon lang kasi ang ating water surface, sakto lang siya dito sa point na to. So, kung sakto siya, pwede tayo mag-form ng triangle dyan. Okay? Sakto siya. So, hindi tayo mahihirapan sa solving. Agad-agad na natin mahanap yung HCP. No? Agad na natin mahanap yung HCP. Distance between water surface and the center of pressure. Okay? Kasi triangle to eh. No? So, this is F1 located at the center of pressure, no? Acting at the center of pressure, and itong part na to ay this is HCP, okay? And this is 2/3 of A, yung HCP na to. So, ang HCP ay 2/3 of A. So, again, centroid ang ating in-apply. Kasi, pag triangle, ang centroid niyan ay nandito, at ang coordinate ng centroid with respect to vertical, no, ang kanyang y component, no, with respect to vertical. So, yung part na to, yung distansya mula dito sa apex ng triangle, no, hanggang sa centroid, no, yung center of pressure. So, yung center, excuse me, yung center of pressure na to, ito yung centroid ng triangle na to. Okay? So, in that case, ito ay 2/3 A. Kasi ito ay A. Yung kabuuan ay A. Okay? At itong part na to ay 1/3 of A. 2/3 of A plus 1/3 of A is A. Diba? So, nandito yung gitnang point. No? Center of this area is at this point. And at that point, that is 2/3 of the value of A from the apex of the triangle down to the center of pressure, which is the centroid of the triangle. Okay? So that is 2/3 of A. So, hindi na tayo gagamit, kahit hindi na tayo gumamit ng E equals to IXC over AHC or HCA, no? IXC over HCA. Pwede naman gamitin to, pero ito yung shortcut. Kapag ka yung water surface ay kapantay yung top part ng ating gate, no? Yung top part, kung kapantay, kung ka-level, pwede natin gamitin yung shortcut na HCP equals 2/3 A, no? So this is now 2/3 of 10 sine 60 degrees, no? 2/3 of A, so ang A natin ay 10 sine 60 degrees kasi nakuha na natin yung A, 10 sine 60 degrees. Okay? And we will get an answer of 5.774 meters. So we can conclude now that F1 is located 5.774 meters below the water surface. No? So it is located 5.774 meters below the water surface. Okay? So we proceed, no? So F2 naman ang ating concern. So tapos na tayo sa F1. Para sa F2. Para sa F2, ganito lang yan. Setting F2. Location of F2 ang ating concern. So, in this case, mapapansin nyo, ito yung ating, balik ko muna. Okay. Itong part na to, itong area na to. Kasi ang ating, ito ay case number 1 ng ating topic. Case number 1, hydrostatic force on a curved surface. So sa case number 1, fluid is above the curved surface. Pag above the curved surface, ito yung ating magiging component ng hydrostatic force F2. No? So yan ang magiging component. So downward. At yung area na to, okay, ay i-consider natin ngayon para sa F2. Okay? Yung area na yan, which is above the curve gate, no? Itong curve na to, yung curve AB, yung above it. Okay? So yung area na yan, so project lang natin pataas, project natin vertically pataas, tapos ito naman ay to the left. Okay? Magmi-meet sila, no? Yung part na to, top point to the left. So ito yung magiging area of interest, no? So yun ang ating concern, kaya ito siya, no? So with that, no? Meron siyang third dimension kasi meron siyang length na 10 meters. Diba? So ito ngayon yung ating yung part na to, kasi ito ay 10 meters, no? Ito ay 10 meters. So magkakaroon ka nga ngayon ng volume of liquid. Ito ngayon yung volume ng liquid. Okay? Na kung saan ang bigat ng volume na to, no, ang bigat ng volume ng liquid na to, which is water, ay katumbas ng magnitude ng F2. Kung ano ang weight ng volume na to, ng tubig na nasa itaas ng gate, AB, okay, ay siya yung magnitude ng ating F2, which is the vertical component of the hydrostatic force. Okay? So with that, ito yung ating hydrostatic force F2, no? And sa area na to, no, let's say halimbawa, hindi siya 3-dimensional, Pero kung 3-dimensional yan, siyempre bandang gitna yan. No? Bandang gitna yan. Dito siya nag-a-act. Pero kung 2D lang ang drawing natin, dito siya ngayon. No? Dito siya ngayon. Okay? So, ito yung ating hydrostatic force acting at the center of gravity of the volume. No? Center of gravity of the volume. Okay? Yung center of gravity ng volume na yan, yung actual niyan nandito. Wala talaga doon. No? Kung 3-dimensional yan, ito yung actual center of gravity of the volume. Okay? Diyan ang kanyang center of gravity. Diyan nag-a-act yung F2. No? So, next, we consider the specific weight of the liquid. Okay? And the hydrostatic force F2, no, the vertical component F2 is equals to the specific weight of the liquid in this figure, which is above this gate, no, AB, multiplied by the volume of this, no. So yung volume niyan, so ay makahanap natin, no. Ating concern natin, ano yung volume niya? So kung mapapansin niyo sa volume, binigyan ko ng ganitong symbol denoting na liquid volume siya or fluid volume, no. So with that, ang volume ng ating figure ay makukuha natin by multiplying the area of the base, which is B, multiplied by the length, no? Okay, BL. So the volume is equals to BL, no? Area of the base times the length. So yan ay lesson ng high school kung naturo man sa inyo, no? Okay. So with that, so ating F2 equals to unit weight of water at 4 degrees Celsius multiplied by BL. No? So we now proceed. No? So considering this triangle, no? Consider natin itong triangle na to. Ito. Okay. Consider natin yung triangle na yan. Ito yan, no? Okay. I-minus natin ito. Kasi ang target kasi natin, malaman yung B. Ano yung B na yan? Ito. Yung part na yan. Kasi ano siya hindi siya common figure. So, ginagawa natin ng paraan para mahanap natin yung area ng base na yan na hindi common figure. No? Kating common figure. So, ang ano natin, solution natin, yung triangle area na to, which is this, i-minus natin dito sa segment area. At yung segment area na yan, i-minus natin dyan. Ito. Itong segment area. No? Minus natin. So, pag minus natin, this will be the result. Ayan. Diba? So, ito yung ating area. No? So, ito siya. Okay? So, in this case, ito yung ating right triangle. No? So, sa ating right triangle, i-minus lang natin yung segment. No? So, ito yung segment. Ang tawag dito ay segment. Take note. No? So, we call this a segment. So, then this is a right triangle. So, tapos ito yung irregular shape object. No? So, right triangle minus the segment is this area. No? So, sabihin natin, yung right triangle, meron siyang area B1. Ang ating segment, meron siyang area B sub 2. Ang net area natin or resulting area, no, or resultant area ay magiging B. Okay? Area nito, B1 minus area B2 equals to area B. So, mahanap na natin, no? So, so ang B ay B1 minus B2. No? So, para sa ating triangle, so itong side na to ay A. Okay? And itong part na to ay Z. Ito. Itong part na to ay Z. So, nilet natin na Z. Diba? Ito ay A. Na-solve na natin na nilet ko to kanina na A yan. Itong part na to. Okay? Nilet ko na A. Tapos ito ay Z. Itong part na to ngayon ay Z. AZ. No? And then, ang area niyan ay 1/2 ZA. Area ng isang triangle. 1/2 base times height. Diba? So, 1/2 Z times A. That is common. Alam nyo yan, right? Then, we have the angle of 60 degrees. We have the angle of 60 degrees. So, theta is 60 degrees. So, if that's the case, ito yung ating radius, angle and radius. So, ang segment area, okay, recall your geometry, no? Sa geometry na tinuturo yan ng high school. Kung naturo man sa inyo. So, the area of the segment, no? Yan, segment ng isang circle, no? Ang tawag dyan segment. The area of the segment. Kasi, kung ito yung circle, hatiin ko siya dito, ang tawag dyan ay segment. No? Tawag dyan ay segment. Okay. Ayan. Yung region of space na yan ay segment. Okay? So, ang area of the segment ay ting formula niya, 1/2 r squared, okay, theta minus sine theta. So, 1/2 r squared theta minus sine theta. So, memorize niyo yung formula ng area ng segment segment. Okay? So, and then, ito yung ngayon ng result. B1 is 1/2 ZA, B2 is 1/2 r squared, theta minus sine theta multiplied by L. So, ang resulta, 1/2 of the unit weight of water at 4 degrees Celsius multiplied by, so, finactor out ko muna yung 1/2, ito, tsaka ito. So, pwedeng ilabas kasi common factor siya. So, tapos matitira dito sa loob ng bracket, no? Sa loob ng bracket ay ZA minus R squared theta minus sine theta. Okay? Then multiplied by L. So, given now this, ang A natin ay 10 sine 60 degrees. Diba? Ito yung A natin. 10 sine 60 degrees yan. Sinolve na natin. So, katawa. Okay? So, ang Z natin, so, saan ba yung Z? Ito. Diba ito yung Z natin? Hinahanap. Itong part na to. Ito, Z. Yan ay Z. Okay? So, kung Z yun, ito rin yan, yung Z na yan. Okay? So, yung Z natin ay 10 minus 10 cosine 60 degrees. Paano siya naging ganun? So, analyze natin. Okay? So, ito ay Z. Yung side na to, ano siya? Kung ito ay 10 sine 60 degrees, no? So, ito ay adjacent side ng right triangle. So, kung adjacent, okay, ito yung adjacent side, ito yung angle theta, ito yung hypotenuse. So, cosine siya ngayon. Right triangle. So, cosine is cosine theta is adjacent over hypotenuse. So, in that case, ang adjacent natin ay itong part na to. Okay? Adjacent natin ay itong part na to. Okay? So, ito yung ating adjacent. Tawagin na lang natin na ADJ for adjacent side. So, ang ating ngayong adjacent ay equal sa hypotenuse times cosine theta. So, ang adjacent natin ay hypotenuse. Ano yung hypotenuse? 10 r yun. Cosine theta. So, or that is 10 cosine 60 degrees. No? Kaya naging 10 cosine 60 degrees ito. Kasi kung yan ay adjacent, ang z natin ay, so anong kabuuan na to na haba? Anong kabuuan na haba nito? So ang kabuuan na haba niyan ay, di ba, ano yan? Part of a circle to. So anong tawag dito? Anong tawag dito? Part ng isang circle yan. Ang tawag dito, ang tawag dyan ay sector. Yan ay sector. Okay? Yan ay sector. Itong part na yan. Na kung saan, iting radius, iting radius. Okay? So, pareho ng length. Tapos, ito yung arc. Okay? So, yan ay sector. Ngayon, kung ito ay 10, ito rin ay 10. R din yan, no? Kasi, radius yan. No? Pareho sila ng haba. 10 meter. So, 10 meter din to. Okay? So, therefore, yung z natin ay total length 10 minus yung adjacent na 10 cosine 60 degrees. Kaya 10 minus 10 cosine 60 degrees yan ang z natin dito. Okay? So, kabuuan is 10 minus yung adjacent, yun yung z natin. Okay? So, which is 10 minus 10 cosine 60 degrees. So, and then, we can solve for F2 now. So, 1/2 unit weight of water at 4 degrees Celsius, no, is 9.81 kilonewton per cubic meter. Z is, ito yun, 10 minus 10 cosine 60 degrees. A is 10 sine 60 degrees. Ito, nasolve na natin kanina yan. A equals to 10 sine 60 degrees. Minus 10 squared. Okay. Ang radius natin ay 10 meters. So, minus 10 squared. No? Theta natin is 60 degrees. So, take note. No? Ito dapat ay naka-radian. Ito ay naka-degree. No? So, kung naka-radian yan, i-multiply mo yung 60 degrees ng pi over 180 degrees para maging radian siya. Okay? So, tapos itong theta remain as degree. Provided naka-mode degree ang calculator natin, no? Dapat naka-mode degree. Pag naka-mode degree, i-convert mo itong 16 in terms of radian. Okay? So, i-multiply mo ngayon ng pi over 180 degrees, yung 60 degrees. Okay? Tapos, minus natin ng sine 60 degrees, which will remain in degree. No? So, yun ang rule para sa pagkuha ng answer nito, no? So, we proceed. So, ang sagot ay 1,235 kilonewton, no? 1,235 kilonewton. Okay? So, tapos meron pa pala, length. Length na 10 meters. So, alam na natin yung length na 10 meters. Ito, times L. So, yan ang sagot ng F2. So, note, no? The resultant hydrostatic force passes through point O. Ito yung point O. No? Ito yung center of a full circle. So, yan ang center of a full circle. Okay? When extended, that will make moment at O equal to 0. No? So, in that case, ito yung F1, ito yung F2, ito yung F. Yung F na yan, dahil circular naman yan, arc naman yan, okay, magpa-pass through sa center, na, sa point O, yung center point. Kung extend natin yan, magiging circle yan, right? Full circle, no? The resultant hydrostatic force passes through O, center of a full circle. Now, when extended, pag yung circle, yung part na to ay extend natin, no? Okay? Passes through O when extended. Okay? That will make moment at O equal to 0. Okay? So, dahil nagpapass siya sa point O, yung ating hydrostatic force, pag nag-moment tayo sa point O, lalabas 0 ang sagot. Dahil pag yung force dumadaan sa point, ang moment niya ay 0. No? Ang moment ng isang force na dumadaan sa point na imo-moment, no? Kung yun ang reference natin, kung dumadaan yun doon yung force, ang moment ng force na yun with respect to the reference ay 0. Naaral nyo yan sa engineering mechanics, no? So, no need to elaborate, no? So, therefore, summation moment at O equal to 0. Okay? So, considering clockwise direction as positive. I-consider natin yung clockwise direction as positive. So, ito yung magiging, resulta. So, consider muna natin itong part na to. No? So, Z-bar. Sabihin natin Z-bar. Okay? So, distance, no? Between point O and the center of gravity. Kasi, ang force F2 dumadaan sa center of gravity ng volume. Diba? Center of gravity of the volume. So, in that case, sa part na to, dumadaan sa center of gravity of the volume. So, kailangan alamin natin yung distansya na to para makapag-moment at O. Okay? So, in that case, Z-bar should be determined. No? So, we are to determine Z-bar, which is the coordinate of the center of gravity of volume. Coordinate yan ng CG, no? Yung center of gravity ng volume. Okay? Yung Z-bar. So, in that case, so meron tayo ditong F2 times Z-bar. Okay? F2 times Z-bar. Dapat perpendicular yan, ha? Okay? So, yun. Tapos, ito naman, pa-counterclockwise with respect to O. Pa-counterclockwise siya, di ba? Okay? Sorry, clockwise. Clockwise ba to? Okay. Considering counterclockwise direction, as positive. Ito counterclockwise, no? Okay? Ito yung ating counterclockwise as positive. So, nasa inyo naman kung gusto niyo yung clockwise na positive or counterclockwise na positive. Pareho pa rin na magiging sagot, no? Okay, pareho pa rin na magiging sagot. So, ito yung ating counterclockwise direction. So ito yung F2. Ang moment niyan with respect to O ay direction niya is counterclockwise. So kung counterclockwise, positive, no? So positive. So F2Z, no? Minus F1 times itong A minus HCP, no? So itong part na to, yung distansya na to ang tinutukoy. Kung ang kabuuan niya ay A minus itong HCP. Okay? So F1 times A minus HCP. Yun ang moment at O. No? So F2Z minus F1 A times A minus HCP equals to 0. Okay? F2Z bar minus F1 times quantity A minus HCP is equals to 0. Okay? So we have now Z bar equals to, so pwede natin i-transpose sa kabila, no? We have F1 A minus HCP all over F2. Ayan, no? So, ang mangyayari ngayon ay substitute na natin. Ang magiging resulta ay ano? So, ang F1 natin ay nasagot na natin kanina, 3679 kilonewton. Ang F2 natin ay nasagot na 1235. 1235 kilonewton. Okay? So, 1235 kilonewton. Okay? Ang ating A, ano yung A natin? A is 10 sine 60 degrees. No? Okay? A 10 sine 60 degrees. Ang ating HCP ay nasagot na yan kanina, 5.774 meters. Okay? Yan. Okay? So, we will get an answer of 8.598 meters. So, we can now conclude F sub 2, the horizontal component, no? F sub 2, the vertical component of the hydrostatic force is located 8.598 meters to the left of O, no? So, ito 'yon. Ito yung O, to the left of O. Ito yung Z bar, which is 8.598 meters. So, F sub 2 is located, or F sub 2 is acting 8.598 meters to the left of O. So, yun ang ating final answer para sa location of F2. Okay, so we're done with this problem. So, we can now proceed. So, here's the next example. In the figure shown, determine the horizontal and vertical components of the total force acting on the cylinder per meter of its length. So let's analyze. So we're going to find for F1 and F2. Okay. So required. So F1 and F2. So let's solve first for F1. No, consider this imaginary lines. No. And we are to determine F1, which is the horizontal component. So to determine F1, we will construct the vertical projection of this curve part, no, of this curve, no, which is curve AB or curve BA. Yan. Okay? So, in that case, consider natin vertical projection na yan where the hydrostatic force is acting. So, here's the center of pressure of the vertical projection, and this is the location of the hydrostatic force horizontal component, no? And take note, per meter length. Ibig sabihin niyan na kada 1 meter length sa third dimension. Okay? So, 1 per meter length. Okay? So, force F1 is formula, alam niyo na yan. Unit weight, hc times area. So, ito yung ating centroid, no? Centroid ng vertical projection, no? So, ito yung hc na ngayon natin. Ito yung hc. Ito. Okay? So, then, ito yung A natin. Ito yung A. So, ang ating solution, the unit weight of the liquid is, which is water, is assumed at 4 degrees Celsius. Ayan. HC is what? Ito, 4 plus yung centroid, no? Yung para sa centroid ng rectangle na to, 1/2 A, no? 1/2 A, yung coordinate ng centroid, 1/2 A. So, 4 plus 1/2 A. Okay? Ito siya. Then, the area. So, the area is base times length times width. So, ito yung width. Ito yung length. No? Ito yung width. Ito yung length. Which is A. So, BA. No? Ito na, take note ha, yan na yung right side view natin. No? Right side view. Shortcut na. Senior cut ko na. Right side view na yan. Okay? Right side view of the vertical projection. No? So, let's draw a triangle. Itong part na to. Ito. Let's draw a triangle. So, this is A. No? Ayan yung A, yung vertical projection. So, ito yung radius ng ating circle. No? So, kung therefore, ito ngayon at saka yun ay pareho din. RR. So, 2R. Meron tayong 2R. No? So, ating angle, 45 degrees. Okay, paano ko yung 45? Okay, ito ay 45. Okay, ito ay recall your geometry. Kung meron na akong 2 parallel lines, no? Tapos meron tayong transversal. Okay? Ito ay lesson sa geometry, no? So kung meron akong 2 parallel lines, tapos meron na intersecting line na tinatawag nating transversal, ito. So in that case, kung ito yung 45, ito ay theta, ito rin ay magiging theta. No? Ang tawag dyan, alternating angles. So, sa case na to, alternating interior sila. Alternating interior angles. So, itong alternating angles, no, dahil parallel naman yung dalawa na to, dahil parallel, magiging equal sila in measurement. No? Basta yung dalawa na to ay parallel, equal in measure yung dalawang angle na yan. Okay? Lesson yan sa geometry in high school. So, this will be 45 degrees now. So, kung 45 yon, take note, no? Ang circle na to ay tangent sa point na to. Pag sinabi kong tangent, it touches at a single point dito sa surface na to. No? So, kung ganon, meron tayong property para dyan. So, kung tangent yan sa surface, 90 degrees. 90 degrees yung angle na to, 90 degrees. Okay? Kasi tangent siya dito. So, magiging 90 degrees ngayon ito. So, kung 90 degrees yan, no? Kung 90 degrees yon, ito ay 45. 45, 45. Therefore, yung remaining 45 degrees. Para maging yung total na 90 degrees, no? Para yung total maging 90 degrees. So, 45 degrees. So, kaya naging 45 yun. Okay? Ganun siya. Ito ay A, di ba? Ito ay 2R. Ito ay 2R. No? So, I hope you get it, no? So, ang 2R natin ay 6 meters. Ang radius kasi ay 3 meters. So, and then, ating magiging ating solution. The unit weight of water is at 4 degrees Celsius is 9.81 kilonewtons per cubic meter multiplied by 4 plus 1 half, that is 0.5. A is, ito yung A, 6 sine 45 degrees, no? A is 6 sine 45 degrees, no? And then meter, no? So, and then B is 1 meter, no? So, ito yung ating B. Okay, paano muna nakuha yung 6 sine 45 degrees? So, katawa ulit, di ba? So, bigyan ko kayo ng shortcut para hindi na tayo nagsusokatawa palagi, no? Ito ay, sabi natin Z. Or, okay, yan ay Z. Ito ay theta. Okay. Ito ay A, ito ay B. O kaya C na lang. Bigyan ko kayo ng shortcut. Ito ay theta. Ito ay A, ito ay B, ito ay C. Kung nandito yung angle, okay, kung nandito yung angle, adjacent. Pag adjacent, cosine. Okay? So, sabihin niyan, C cosine theta. Nandito yung angle, ay nandito yung side A, na opposite sa kanya ay theta, so sine. So, kaya C, hypotenuse, sine theta. Ganun lang ang shortcut. Kaya, 6, kasi A ang hinahanap natin, ito, 6 sine 45 degrees. No? 6 sine 45 degrees. Okay, kaya naging ganun siya. Okay? And then, BA, no? B is 1 meter, A is 6 sine 45 degrees. So, we will get an answer of 254.8 kilonewtons. So, that is per meter length. No? Kada meter length, no? Merong 254.8 kilonewton. Sabi-sabihin niyan, sa area na to, okay, merong 254.8 kilonewtons na hydrostatic force ng location ay nasa center of pressure. No? Okay. So, we proceed. So, next is F2, finding F2. Ang F2 natin ay, ito kasi, sa case na to, the water is above the curved path. No? Water is above, water is below the curved path. no? Water is below the curved path. So, in that case, analyze natin. So, case 2. So, case 2 ito. So, ito yung ating F2. So, ito siya. Okay. Ito yung F2 at ito yung kanyang nasasakupan. Ayan. Yan ang kanyang nasasakupan na area. Okay. So, yan yung nasasakupan niya. Ayan. No? Okay. So, pag case 2, no? So, we have here imaginary volume. No? Imaginary volume full of liquid. No? So, ganun yung process. It's not real liquid, pero imaginary liquid. Ini-imagine natin na merong likido, merong tubig sa loob, no? Sa nasasakupan na area ng F2, no? So, we analyze further. So, alam natin, ito yung A kanina. At ito ay isang composite area. Take note. Composite figure. So, in that case, may part na circular, may part na parang rectangle, no? Okay. Kombinasyon na siya, no? Kombinasyon na siya. So, in that case, ito yung projected area natin. Ito yung area natin para sa F2. And the F2 acts at this point, which is the center of gravity of the volume. No? So, in that case, ito yon. Okay. So, in third dimension, kasi per meter lang ito. No? Per meter lang. So, with that, consider natin to. Ayan. Okay? So, yung volume yan, hanapin natin. Okay? So, next. So, ito ay 1 meter. No? Kasi per meter lang. 1 meter. So, we consider the specific weight of the liquid. Then, the area of the base. No? Ito yung area na yan, ng base natin. Na concern natin. Okay? So, ini-imagine natin na there is liquid above this curve AB. Itong curve AB na yan na there is liquid above it. Okay? So, yun ang ini-imagine natin. Okay? So, at yung bigat niyan ay katumbas ng F2 value. I-assume natin na ito ay merong tubig kasi water ang ating liquid, no? So, tubig yan at yung bigat niyan ay katumbas ng F2 value natin, no? So, ating 1 meter length, no? So, F2 is equals to unit weight times the volume, no? The liquid volume. Diba, ang specific weight natin ay weight over volume. Okay? So, ang weight ng isang bagay ay unit weight times V. So, yung weight na yan ay equal sa F2. No? kung ano ang bigat ng tubig na yan ay yun din yung F2. Okay? So, niligyan ko lang ng ganitong symbol for water, for the liquid. No? So, F2 is equals to unit weight of water at 4 degrees Celsius multiplied by BL. No? So, ito yung ating itong part na to. Ito ay semicircle, right? Semicircle yan. So, kung ito ay semicircle, itong part na to ay semicircle. Okay? And then, so kung yan ay semicircle, add natin itong trapezoid. No? By the way, ang area ng semicircle, no, ay 1/2 pi r squared. Ang pi r squared ay area ng circle. Okay? Kalahati ng area ng circle is the area of the semicircle. Then, this is the radius, 3 meter. So, sabihin niya na itong diameter ng ating circle, 2r, no? So, i-add natin yung area ng, so anong tawag dito sa quadrilateral na to? Kung alam niyo pa yung geometry niyo. Ang tawag dyan ay trapezoid. This is trapezoid. So, kung yan ay trapezoid, ano kanyang property? Paano siya naging trapezoid? No? Para sa trapezoid, may dalawang line, one pair of lines, no, is parallel. Sabihin niyan, one pair of lines is parallel. Itong part na to at saka itong part na to ay parallel. Itong pair na to, no, parallel. At yung next pair, yung second pair ay hindi parallel. Pag parallel yung dalawang line na to na pair, no? So masasabi natin na trapezoid provided hindi parallel yung second pair, ito at saka ito, no? So masasabi natin yan ay trapezoid, no? So next, so yan ay trapezoid. So ito ay 2r. Okay. Then this is y1. Okay. Yung height na to ay y1. Yung height na to ay y2. Yung side na to ay z. Nilat ko to na y1, nilat ko to na y2, nilat ko to na z. Okay. So para dito, yung trapezoid, para sa part na to. No? Ayan. Para sa part na yan. Okay? Ito. So, ang area ng trapezoid, okay, ay makukuha natin using the formula na to. Ayan ay topic sa geometry. So, recall your geometry, no? In high school, ang area ng trapezoid ay 1/2 the sum of the two bases, y1 and y2, no? First base, second base. So, yung first base, second base, yun yung pair of parallel sides, no? Yung sides na parallel, yung pair of parallel sides. So, y1 plus y2. Then, multiply natin yung altitude. Yung altitude, yung z, yung perpendicular distance between y1 and y2, no? Itong distansya, no, between y1 and y2. Okay? Yung perpendicular distance ng dalawa. Okay? Na tinatawag nating altitude, no? Or height, no? Altitude or height. Okay? Kasi pwede naman natin na gawing ganito. Nandito yung Z, nandito yung Y1, nandito yung Y2. So, kumbaga, yung altitude na yan, yun din ang height. No? Height ng trapezoid. No? Kaya lang, ganyan siya nakaporma eh. No? Pero pareho pa rin, no? Okay. So, equals to, yung pinagsamang dalawa. Kasi ito, irregular shape object. So, ang semicircle, common. Ang trapezoid, common. So, ang semicircle, alam natin ang area. Ang trapezoid, alam natin yung area. I-add natin yung dalawa. Magiging total area ng isang composite figure. So, ito ay isang composite figure, irregular shape. No? Okay? So, F2 now is unit weight of water at 4 degrees Celsius multiplied by B1 plus B2 multiplied by the length. No? So, ito yung ating. So, consider natin itong triangle dito sa part na to. Okay? So, ito ay 45 degrees. Ito rin yan, no? Ito rin yan. Ito ay, kasi kanina, di ba, 45 ito? Okay? Na-derive natin na ito ay 45 degrees. So, therefore, 45 din ito. Alternating interior angles, di ba? Okay, so, kaya 45 siya. Ito ay Z, okay? Ito ay Z. Okay. So, ito yung Z natin. Okay. Then 6 meters. Okay. 6 meters, no? Ito. Distance between A and B, 6 meters. Twice the radius, no? So, ang ating Z ay 6 cosine 45 degrees, no? So, katawa, ang Z malapit sa 45 at ito ay right triangle. Kaya 6, dahil malapit, adjacent, pag adjacent, cosine 45 degrees. Yun ang shortcut, no? 6 cosine 45 degrees meter, no? So, ito ay 6 sine 45 naman. Malayo. Malayo. At nasolve na natin yan sa nakaraang sa previous slide, no? Yung A. Next. So, yan. So, in that case, substitute natin yung mga given. Unit weight of water, okay. 9.81, okay. B1, 1/2 pi r squared semicircle. Ayun. Ang radius kasi ay 3 meter, no? Then, B2, trapezoid, 1/2, Y1. Ang Y1 natin yun ang 4, di ba? Y1 is 4. Okay? Ang ano natin, Y2 natin ay, ang Y2 natin ay itong haba na to, 4 plus itong haba na to. Ano yung haba na to? 4 plus, this is 6, ito yung 45. 6 sine 45 degrees. So, 4 plus 6 sine 45 degrees. Diba ito yan? Ayan. No? Yun ang Y2. Okay, yun ang Y2. Ang Y2 ay itong 4 na to plus 6 sine 45 degrees. 4 plus A. Ito yung A. No? 4 plus A. Okay? So, and then, yan ang y2. Ito yung y1. Ito yung y2. Then, ito yung ating z. Ito yung ating z. Ang z natin ay 6 cosine 45 degrees. Nasolve na natin sa previous slide yan. Okay, nasolve na natin sa previous slide yan. No? Yun ang, yun ang para sa z. No? And then, length. Length ay 1 meter. Per meter length, di ba? Per meter length. Kaya nag-arrive tayo sa 393.5 kilonewtons. Okay? So that ends my presentation. So I hope you get it, no? So, ano ko lang. So, F2 per meter length natin ay F2 per meter length is equal to 393.5 kilonewtons, no? Okay? So that ends my presentation. Good day, everyone.